One of the big issues that we deal with in games is having to compute something that takes a long time to finish. For example, if you do A-star pathfinding, it might take more time than a single frame to figure out what the next destination is supposed to be. In other words, you have to add things to queues, you have to remove them, and you have to calculate the path, the optimal path, to the destination. And this really can take a long time, especially if you're trying to do this every frame. Part of the issue is that we often think of game engines as having a main game loop, and really Unity is no different. See, in our scripts, we write an update method, and we expect this to be called every frame. But if you're doing something complex, you might not be able to finish that computation during the time that it takes to draw a single frame. In fact, in game companies, if you look around or talk to people, you'll often hear about different parts of the game engine having different time budgets. So AI, for example, it can't use all the CPU when it needs it. And A-star pathfinding is a prime example. If you try to calculate the optimal path from one enemy to, say, the player, and then you did this for every enemy, and you try to do this every frame, you're gonna use up all the CPU, and you're not gonna have any time left for rendering. In C# and Unity, we have something called a coroutine that can sort of help with this. Now, these are widely used, and they're used smartly. And what I mean is that sometimes you'll find developers who believe that they can optimize better than the compiler can, and so they'll do all sorts of tricks to break up their algorithms manually and run them in the update method, and then they'll highly discourage you from ever using a coroutine. And frankly, I find this silly. I urge you to avoid this sort of behavior. Really, we call this premature optimization, and you'll find developers like this. And it's often, especially when you're dealing with amateur developers who are really concerned about, the speed of their game and making sure they get as fast of a frame rate as possible. These things are important to think about, but if you've learned anything from computer science, a big part of this is about the algorithm that you've chosen and not about little things like the amount of time it takes to queue up and run your coroutines. I mean, you could literally create thousands of coroutines and you barely notice a performance hit as it goes through, the game engine goes through and executes them. And if you interview at a company, and I've heard this happen with my students before, if you interviewed a company where you have a developer who shuns coroutines, you should really ask yourself what's going on. Is this a company filled with a bunch of premature optimizers? And are you going to be wasting huge amounts of your life dealing with bugs because they tried to break up algorithms that were much more easily expressed by simply using a coroutine? So please, optimize later. The point of optimization is that you build your game, you profile it to figure out where the slow parts are if you're having performance problems in the first place, and then you figure out what the biggest impact items are. And so don't break apart your game just because you want to get rid of all of your coroutines or some developer told you shouldn't do that. First, you build your game, get something working, get funding, whatever, and then you can worry about the optimization at a later point. So what is a coroutine? Well, really it's a way to run code that you can yield the execution of to the game engine periodically. Now, if you think about other systems like threads, which you might have used in other languages like Java, and C# has threads also, to be clear, but Unity expects everything to be running on the main thread. Now, this is just part of the game engine design, so all of the scripts have to run through the C# interpreter and or virtual machine, and so it expects everything to be single threaded on the main thread when you're dealing with game stuff in particular. And so coroutines are a way that basically you can break up your computation into little parts, but you can write them in sort of a natural way like you would if you assumed that you had full control of the main thread. And it often works really well with algorithms that require loops, though you can use it with recursion. You just obviously always have to be careful when you're using recursion because C# does not have tail recursive calls, and so it's not going to necessarily optimize those into loops like other smarter languages like Haskell or Racket might. So let's look at a simple example, and this is what I've set up in my project here. So I have a simple canvas, and I have a timer label, and I have some time left. And so what we'd like to do is figure out how to write a timer object, using a mono behavior in Unity. And, there are other ways to do this, obviously, but a coroutine is sort of an obvious, easy way to do it. And you'll see what I mean by using loops, because we'll just be able to write a loop in order to get this set up. So let's go ahead and create a new script that we're going to put in our system. And so I will say new C# script, and we will call this send message timer. And then we'll open this up and we will create a timer behavior. So let's think about some of the things that we want in this behavior. Okay, so first of all, we want to know how long this behavior is going to last. So we will create a duration, and we'll use a floating point. The reason we're using a floating point is because time is measured by floating point values. And then we are going to set up an end time, but we'll keep this private because we don't need to share this. And the idea is that we're going to just set a duration, and when we start it, it'll calculate the end time automatically. And so we'll also want to have a timer started floating point, Boolean, and this is going to let us know if the timer has started yet. And then we want to attach a game object to this. And this is going to be the called object. And so in essence, we're going to be able to put an object on here that will then have a message called on it every time we need it to be updated. And so what does this look like? Well, when we go into our start function, we want to say timer started equals false. We want to make sure that it's set to false initially. Now, for the sake of our design, we're just going to go ahead and call a method called start timer when we execute. Now, obviously, there's no function called start timer, but we're going to go ahead and define that here in just a second. But the idea is that once this object is spawned, the timer will start. Now, and because we are putting this into a method cleverly instead of doing all the work here, we can then call start timer from somewhere else if we need to. So let's look at what that looks like. So it's going to look something like this. Virtual void start timer. It's not going to take any arguments. Obviously, we're going to say timer started equals true to make sure that it's been started. And then we're going to say start coroutine, start countdown. Now, there is no method for this coroutine yet, but the coroutine method is going to be called start countdown. And it's going to look something like this. Protected virtual enumerator start countdown. Now, one thing to notice about, these methods is that the start countdown method, this object returns something that is called an enumerator. And this should look a little bit familiar if you're used to something like Java. So Java, whenever you have a collection, you have an enumerator on it, and it enumerates, all the elements in there. The difference here is that this enumerator is enumerating computation in a sense. And so you can think of it as being able to have an object that it's going to call next on, and this next is going to return like an object that's going to let it know what the next computation is going to be. So all of this is going to get built up for you. There's nothing really you have to do that's fancy. And you might be wondering why my object is underlined. Well, I'll mouse over it so you can see, but it's telling you that not all codes return a value. And since I'm returning an enumerator, I actually need to return something here. So the simplest thing to do is say yield return null. Now this yield is a new command or a new keyword that you haven't seen before. And what it's doing is this is what's yielding the computation. So at this point, whatever's been done in here, it's going to wrap up and return with the enumerator so that the game engine can then say, give me the next thing in this collection, and it will then do another computation. And yield return null just means, just don't return anything specifically. So just keep doing my computation. But you can return other enumerators. So you can return coroutines from within coroutines. And this will make sense a little bit later when we start setting up like waiting and stuff like that with coroutines. So let's define the rest of this function to actually make some sense for us. So the first thing we want to do is calculate the end time. And so we're going to say it's going to be equal to time.time. So instead of a delta time, we're going to grab the current time plus the duration. So however much time, so when this start countdown is called, we're going to take the current time, we're going to add our duration to it, and that's going to give us our end time. And now it's pretty easy. So let's leave some comments for ourselves. So calculate the end time based on the current time and duration. And then what we want to do is loop until the current elapsed time is greater than the end time. And so what this looks like is something like this. Simple while loop. So time.time is less than end time. So as long as this is happening, we are going to continue to keep checking if this is true. So in other words, this is going to exit whenever our time has passed our end time. And so what we want to do is have something in here that's going to set up the rest of the messaging. And I'm going to use called object here and called object send message. And we're going to call a message called OnTimerTick. And we're going to pass this to it. Now, to be clear, when I call send message, it's going to look for a method called OnTimerTick on whatever we set our called object to. And it's going to pass the parameter called this. Well, this points to our mono behavior. So it's a reference to our mono behavior that's going to get sent to that method. So it's going to expect a method called OnTimerTick with this capitalization that accepts a parameter of type send message timer. So it's going to pass this into it. Now, using this send message is not the most efficient way to call another method, obviously. The most efficient way would be just to call it directly. And the reason I'm doing this is because it allows me to call an OnTimerTick function on any mono behavior that we have. So it doesn't have to be a specific type. And you wouldn't always want to do this. This is just to give you an example of how to do it. It's not the most efficient, but also remember, don't pre-optimize. So unless you're seeing lots of time being spent on doing method lookups in send messages, because you're using it everywhere, then don't worry about it. Okay, don't worry about it until it's a real issue. So instead of, if we didn't have anything else besides this, the game would actually just hang at this point until the amount of time it had elapsed. And that's because we're in a while loop here, and there's no exiting from this while loop. And it would be the same thing as if I had put this while loop in my update method. The game engine just can't do anything else until it's done with your update method. So don't ever put any big loops inside your update method. And here, the way we get out of it is to take our yield return null method, call, and put it up here. And this means that when this enumerator is called, it's going to do this loop. So it'll say time is going to ask if time.time is less than end time. And if not, it's going to call the OnTimerTick on that other object. And then it's going to yield control back to the game engine. And when the game engine sees that, it's going to then see if there's any other, coroutines that still need to be called. It'll call those coroutines, and it'll go back to its normal rendering and physics simulation and everything else that your game engine does, making sounds work and all that. And then when it's time to run the coroutines again, it'll come back. Well, after this yield return null is executed, you can imagine that there's an imaginary sort of cursor pointing to where I'm going to execute next. Well, at this point, there's nothing else to execute, so I'm going to pop back up to the top of my loop and do the same thing over and over again. So that repeatedly, and then at the end, what we'd like to do instead of just returning null is say called object, send message again, and we will say OnTimerExpired. And we're not going to pass anything to it, though we could pass, the timer to it so we could reset it or whatever the other object would like to do. But this will be called at the very end. And so in essence, we've created two methods that can be called. So an OnTimerTick method and an OnTimerExpired method. And we could do delegates. I mean, again, there's all sorts of ways we could do this, but I would not worry about the, optimizing right now. So now that we have this set up, let's add another behavior, and we'll just add this to our canvas, but you could put it on a separate object, to receive this tick message. And so I'm just going to go ahead and create a new script. We'll say create, and we'll say C# script, and we will call this timer update, something like that. And then I will just take this and drag it directly onto my canvas. And let's going to go ahead and put this object here. And then I'm going to take my canvas and I'm going to make this the called object. So before this was set to none, let me just show you really quick here. Normally it looks like that, and I dragged my canvas onto it to set it up. Now this is going to make my canvas a call object. And when I call send message, what it's going to do is it's going to look for that OnTimerTick method on every one of the mono behaviors on this object and every one of my components. So again, this is why I was saying it's not the most efficient way to do this, but it is an easy way to do this. And we can go now to our timer update to set things up. And the timer update can simply, let's make a couple of methods. So public void OnTimerTick, which will need to take an argument of send message timer. We'll just call this timer. And then we'll have a public void OnTimerExpired. This won't take any arguments. And if you don't put the arguments here, if you put a no argument version of this, it's just going to ignore the argument. So it's not going to like crash your game or something like that. But you know, you want to do it if you want to get those values. So let's just start simple and we'll say debug log and we'll say timer tick. And then we'll say debug log timer expired. And then from here, if we just take our game and we run it, and what we'll see is if we look at our canvas here, is that we're getting a bunch of messages for the timer tick happening, and then we're going to, when this is expired in 10 seconds, we'll see that a timer expired event has fired. So now you can see that it was called again. The timer expired event was called on us. So that's basically how you set these up. But what we'd really like to do is print the time left here in our system. And so we have to do a little bit more setup on our timer to make this work. Now what we want to do is create a function that's going to calculate the, how much time is left. So let's write a function to do that. So we will call this time left. And this will simply calculate, how much time is necessary for this timer to end. So we'll do a little check here. So if timer started equals false, then we'll just return 0. Else, so we just want to make sure that the timer's actually been started, and so we'll say the end time, so we know what time it's going to end at, minus time.time. This will tell us how much time is remaining, and we're just going to return this value here. So this will calculate how much time is left, and then you could change your code a little bit if you wanted to. So since we're doing this calculation here, you could say like, is time left greater than 0 or something like that. Well, this is fine as it is though. So now that we have this time left function, we can then take this value over here into our send message. I'm sorry, our timer update. And instead of calling timer tick, what we want to do is set the text of our text value to be however much time is left. So we do that by getting the component, and so we can just say get component in children. We're going to get it on all the children because we want to make sure that we have the right object. The one thing that you need to make sure is that you have unityengine.ui set up here so that it'll find the actual type that we need, which is a text object. And we're going to just say GameObject here, get component in children. And then this is going to give us a text object that we can use. So we can say, text equals this. It should grab the first one. And so you want to make sure also that the time left is the first one. So originally I had it as a second. I moved it up to the first. Oops, I don't want to move it on top of there. Is the first object, because it's going to go in order of the components. And so it's going to just grab me the first one. But if you're not doing that, you can get all of the components of type text, and then you can figure out which one it is by setting values in those objects themselves. So from this, we can say now text.text equals, and here's a little trick for you, empty string plus timer dot time left. This is going to return that floating point value, which will then be converted to a string to be concatenated to here. So little trick for you there. So that should update our timer at this point, and then when we run it, we'll see that our time is going to be however much time is left. So let's take a look. We'll hit play. We can see our timer counting down, and then at the very end, at this 10 seconds, it's going to be whatever the last value was. And what you'd want to do is set it up on the timer expired so that this goes to 0. So let's take a look at how we do that really quick. Here, we can just say, grabbing this, and then text equals 0. Now, as a quick point of concern you might have, I'm calling getComponent in children every tick again. You don't need to do this here. You could just create a text object up here like this, and then you could do this code up here like this, and then you don't have to do this every time, so that you're only doing it at the start. Now these objects will be created, so we don't have to worry about it, and then we'll only just access the object directly through a reference. So this is a much nicer way to do this, and I do recommend doing this. It's kind of like premature optimization, but getting components every single time just does seem like kind of a waste, and it's a linear operation especially. The first one is just going to get the first one, but it has to look at all the children, right, to figure out which one has that text object. So that's an example of where we're changing the algorithm, because instead of being a linear operation that happens every tick, we've changed it to a linear one that happens at the beginning of the game, and then a constant operation that happens every time. And so with this, we should see that when it counts down and gets to 0, that it will actually just print 0. Also, my text is going to wrap as it gets really small, mainly because I didn't give very much space to this text field, but that's not a big deal. You could set it the way you want. And then that's how we know the timer's expired, and you could reset the timer or do various tricks to it, just like that. So that should give you an idea of how a coroutine would work, for a simple idea of creating a timer or a simple algorithm. We could do more complex things like creating some kind of patrol system, and so let's do that next to see what that looks like.